Okay, fine. So the agenda is the stop and wait protocol. Okay, we will see how to write an NS2 code for stop and wait protocol for the simulation of the stop and wait protocol. Okay, let me just go to the program. So this is the agenda. Okay, I'm planning to create 6 nodes. Okay, so out of the 6 node, this is my source node, node 0, and node 5 is the destination node. Okay, so how to write a code for getting an NAM window like this. Okay, and here I am going to study the behavior of the stop and wait protocol. Okay, wow. So how to write the TCL script file? Okay, in NS2. Let me just go to the program. Okay, I will explain step by step. I hope that you know already the basics. Okay, so we have already seen the wired scenario for 2 nodes. Okay, how to establish a link between 2 nodes N0 and N1. Okay, and we have seen how to write a TCL script file. Okay, for a wired scenario, simple wired scenario. So assume that you have already have seen this video. Okay, so with the assumption that you know the basics, okay, which are all explained in this video, let me just proceed. I will go to the program. Okay, so we know that in NS2, the first and foremost step in NS2 is, let me just take the, okay, the first and foremost step is to create a simulation object. Okay, so the first step, and so let me just skip the basic things which are all already explained in that video. I will just move on to the important points. Okay, so the first step is to create a simulation object. So, and we have done. The second is to create nodes. Okay, so here our aim is to get an output like this. Okay, so to get an output like this, so I have totally 6 nodes. Okay, so I am writing node 0 $ns node, it will create node 0. So likewise up to n5. Okay, so I am giving the label as n5. Okay, so $ns node, so I have created totally 6 nodes. Then for each and every node, okay, I'm using different colors. Okay, so you can see purple, pink, like that. So I'm mentioning that. So so that is the next step. Okay, so $n0 for which node, whichever node you have to mention $n0. So $n1 in purple. Okay, like that. So next step is, okay, I'm mentioning the node shape. Okay, so we have seen, so here we have chosen box type. Okay, so box type, each and every node it is mentioned box type. So I'm mentioning the shape box, the shape as box. Okay, then also we can see for each and every node. Okay, I'm going to start the I'm going to run my simulation starting from 0.0. Okay, so here it is mentioned $ns at 0.0. Okay, and for each and every host, okay, I'm going to mention like system 0, system 1, system 2, likewise. Okay, so this is for labeling, just for labeling. Okay, now, so we have created a simulation object. The next step is to open a NAM file. Okay, so for stop and wait, I'm just writing it as stop wait.nam. Okay, stop wait.nam. So while we are getting the NAM window, while after running the simulation, okay, it will show the name of the NAM as stop wait. Okay, and I'm going to write it, so it is W. Okay, so we know the next step to record all the contents of NAM file inside my simulation object NS. Okay, so why NS? Because the simulation object name, what I have given as NS, the simulation object name I have given as NS. Okay, wherever is set it is user defined. So since the simulation object name is NS, so here, so it is given. So from $NF NAM trace all to this $NS. Okay. Then Also here I'm adding trace file. Okay, so to open that trace file, it is open stop wait dot trace. So students, in case of NS2, okay, the output of your NS2 is trace file. Okay, so to open that trace file, okay, so we have this command. So within a square bracket, okay, open stop wait dot tr. Okay, so you have to know we are doing two kind of outputs here. One is dot nam, another one is dot tr. Okay, so nam, it will show the animation. Okay, it will show the animation, and the trace, it will show all the events. Okay, so like in a command prompt, okay, it will show all the events which are all happening, whether packet transferring is happening, okay, whether packet dropping is happening. So that is called the trace file. Okay, so also I'm going to record all the trace contents into my simulation object. So these are all the steps we have to do. Okay, so how we do hash include stdio.h, we will be including the header files. Okay, then we will be main of, okay, in case of C program, okay, then we will declare the variable. Likewise in NS2 they have built like this. So we have done the simulation object created, then we have created the nodes. Okay, then we have created the nam, we have opened the nam, and we have opened the trace. Okay, so next is main, then in network I have to establish the link between the nodes. So that is the next step. Okay, to establish the link between node, we already discussed the syntax. Okay, so dollar name of the simulation object space type of the link space starting node ending node, then bandwidth delay queue type. Okay, wow. So here we have seen we have up to 6 nodes. Okay, so to the 6 nodes I need to have the connections like this. Okay, so I have to establish a link between 0 to 2, I have to establish a link between 1 to 2, I have to establish a link between 2 to 3. Okay, so like this I need to have. Okay, so the orientation, it should be like this. Okay, so I have to say the node positioning. So in my code I have to mention my node positioning. Okay, so that is the next step. Okay, so for this, what is the command? Duplex link. So I'm saying it is a bidirectional. In either way the communication is possible. Duplex hyphen link hyphen op. Okay, so this is a command for the node positioning. So in node positioning I can mention like right up, right down. Okay, then left up, left down. Okay, right, then left. So if it is right means it is 0. Okay, wherever if I have right, it is mentioning that, so it is at 0 angle. Okay, if it is a right up, it is at 45 degree. If it is right down, it is minus 45 degree. Okay, so here, so I'm establishing link between n0 and n0 and n2. Okay, then how I have positioned n2 from n0. Okay, so from n0 n2, it is right down. Okay, we know that. So for right down, it is minus 45 degree. Okay, from n0 to n2, it is right down. Okay, you just see n0 to n2, it is right down, so minus 45 degree. Okay, so I know you know the quadrant. So you know the quadrant. So this is plus 45 degree. Okay, plus 45 degree plus 90. So this is 135 degree. So the likewise we know this is plus 45 degree, and this is minus 45 degree. Okay, so they have mentioned, so that in the code. So orient right down. Okay, next okay, the same steps, these are all the same steps, students. So wherever you have this syntax, it is for the link creation. Okay, wherever you have duplex link op, so it is for the node positioning. Okay, so it will fall in any one of this category. Okay, right up, right down, left up, left down, up down. Okay, so up means 90 degree, down means minus 90 degree, right up means plus 45 degree, right down means minus 45 degree. Okay, so next, so we can see so we completed this one now. So here they have mentioned the Q limit. Okay, so in the previous video, okay, we haven't seen like Q limit. If it is not mentioned, it will take the default value as a 50 packets. What is actually a Q? Okay, so what is the Q size? Okay, so we will be having a buffer. Everything will be stored in the buffer. So from the buffer it will take one by one. This is the basic concept we know. The same thing. Okay, so from N0 to N2, okay, the Q size here I have mentioned as 10. It means that the Q size is set to 10 packets. Okay, suppose if it is not mentioned, the default value will be 50. Okay, so even if you skip the step, it will be having a default value in the TCL script. Okay, so it will take that value. Okay, then now the next step, so we have created a link between N1 and N2. Also we have mentioned N1 to N2 it is orient right up. Okay, so right up means plus 45 degree. So you just see, so 1 to 2, so it is at plus 45 degree. புரியுதா? So you have to அந்த quadrant மாதிரி எடுத்துக்கணும். இந்த மாதிரி 4 quadrant எடுத்துட்டு plus 45 னா இங்க இருந்து இது எது வரும்? இந்த position. So here I am positioning my node 2. Okay, so நம்ம எப்படி சொல்றோமோ அதான் அது அந்த மாதிரி தான் அது ஜெனரேட் பண்ணும். So that is the thing you should remember, students. So this is not the fixed program, I can say. Okay va? So whatever type of network, okay, you have in your mind, or whatever the given problem, so accordingly you have to write the code. This is not the fixed program for your stop and wait protocol using NS2. Okay, so N1 to N2 I have completed now. So next again what I'm doing, I'm establishing a link between N2 and N3. Okay, so N2 and N3. Okay, so I'm saying orient right. Okay, so if it is right, I have mentioned already, it is 0 degree. Okay, you just see N2 to N3, it should be positioned like it is at an angle of 0. Okay, so that is why we have mentioned in the code like this. Okay, so N2 to N3 orient right. Similarly, we can see I need to have my N4 and N5. Okay, so N4, so from N3 it should be right up plus 45. My N5 it should be at minus 45. Okay வா, இந்த மாதிரி ஒரு quadrant மாதிரி எடுத்துக்கோங்கப்பா, கன்ஃபியூஸ் பண்ணிக்காதீங்க. quadrant மாதிரி எடுத்துட்டோம். This is at plus 45, so this should be in minus 45. so இங்க right up னா போணும், இங்க வந்து right down அப்படின்னு எழுதணும். So I have to mention from N3 to N4, here from N3 to N5. Okay, so here $NS duplex link op. Okay, I hope you understood. Down the link creation N3 N4. So link creation la enna irukum, $NS name of the simulation object, type of link, space, starting node, ending node, அதாவது first node N3 to N4 தான link சொல்றோம். அப்ப N3 $N3, then we have $N4. so this is bandwidth 0.2 Mbps, delay 20 millisecond. Okay, so all these value we are only fixing. Okay, it doesn't mean that this is the permanent value. Okay, so drop tile is a Q type. So in all the link creation you can see, so we are following the same syntax. Okay, we are just varying the node. Okay, so now we are so here the code it is written for N3 to N4. so I have mentioned $N3 $N4. Okay, so this is right up. Okay, why right up? Because from N3 to N4 it is at plus 45 degree. Okay, now my N5 it should be at minus 45 degree. so I'm mentioning $NS duplex link op. Okay, students, please remember for node positioning, so duplex link op is the command we are using in NS2. Okay, so that is duplex hyphen link hyphen op. Okay, so NS2 ல அப்படிதான் அந்த கமாண்ட், இந்த கமாண்ட்னா அது வந்து நோட் பொசிஷனிங்க்கு கொடுத்திருக்கான். ஓகேவா? ஸோ அதுக்கு வந்து வில் பி ஹேவிங் அதுக்கு நிறைய நம்பர் ஆஃப் பேஜஸ் வந்து கோட் எழுதியிருப்பான். ஓகேவா? ஸோ அதை பற்றிலாம் எல்லாம் அவங்க ஆல்ரெடி டெவலப் பண்ணிட்டாங்க, நம்ம அதை மட்டும் எடுத்து யூஸ் பண்ணுறோம். ஓகேவா? அதை மட்டும் நீங்கள் தெரிஞ்சுட்டா போதும். ஸோ N3 and N5, it is orient right down. Okay, so right down it is minus 45 degree. So now we have completed the node positioning. Okay, so what are all completed? So we have created simulation object, then we have opened NAM file, we have opened the trace file. In the previous video NAM file மட்டும் தான் பார்த்தோம், but here we are also seeing trace file. Okay, so don't confuse, trace file means it is the output of your NS2. Okay, so in NS2 while running your experiment, okay, so it will display all the events. Okay, packet dropping, packet transferring, so that is nothing but your trace file. In NS2 we are calling it as a trace file. Okay, so we have opened the trace, sorry. Next is node creation we completed, then next is the link creation. Okay, so everything we completed. What is the next step? So in the next step I have to create my communication agent. Okay, so we have some parameters. Okay, so since in stop and wait protocol, okay, here we are using the source communication agent as TCP. So we need to define some configuration parameters which are all related to your TCP. Okay, so that is the purpose we have here this line. Okay, the trace var, that is the variable tracing. Okay, I'm using variable trace in NAM. Okay, so this is the line you have to mention. Okay, now so here I have to mention what is my source communication agent and what is my destination communication agent. Okay, my source communication agent is TCP, my destination communication agent is TCP sync. Okay, so we have different types of communication agent. Okay, in the previous experiment we have seen, so UDP as the source communication agent and null is the destination communication agent. Okay, so similarly we have here we are using TCP as my source communication agent and TCP sync as my destination communication agent. Also I have to mention which is my source node and which is my destination node. Okay, so here I am taking N0 as the source node and N5 as my destination node. Okay, so நம்ம என்ன கொடுக்கிறோமோ அதுதான் வந்து அதை எக்ஸிக்யூட் பண்ண போகுது. Please remember. Okay, I am again repeating, this is not the fixed code. Okay, so நமக்கு எப்படி வேணுமோ, என்னோட நெட்வொர்க் வந்து எப்படி வேணும், எப்படி வந்து பாக்கெட் சென்ட் பண்றேன், so everything we are mentioning in the code, so that is how it will be executed. Okay, so now I am mentioning, so this is my source node and this is my destination node. Okay, so now we are going to transfer the packet from N0 to N5. So I have to attach my source communication agent with N0 and I have to attach my destination communication agent with N5. Okay, so for attaching the agent, so we know we have a command attach agent. So N0 to the TCP, $N0 to the $TCP. So these are all the configuration parameters for the TCP. Since I have used TCP, so in TCP I have certain important parameters. The most important value that determine the behavior of the TCP is the congestion window size. Okay, so wherever you have CWND, remember it is congestion window. Okay, so this is for the flow ID. So these are all the configuration parameters we have to mention. Okay, so இப்படி C programல வந்து ஒரு வேரியபிள் வேணுமா நீ டிக்ளேர் பண்ணுவியோ, அதே மாதிரி நான் TCP agent யூஸ் பண்றப்ப இந்த configuration parameter எல்லாமே நான் வந்து என்ன பண்ணும், I have to describe it. Okay, so that is, and these are all related to the TCP configuration parameters. So we have mentioned it is $TCP. Okay, so and so I am attaching to N0. Why N0? Because here I am using N0 as a source agent. Okay, now so to create, so we know this is the syntax, right? To create a communication agent. So new agent under that subtype as TCP. Okay, similarly for destination communication agent, my destination communication agent is TCP sync. Okay, so new agent, so under that subtype is TCP sync. Okay, so what is my destination node? N5. So I am attaching, so why here I am using $sync? Because I have given in my destination communication agent, okay, I have given the name as sync. So $N5 $sync. Okay, so now what is the next step? So I have created nodes, I have established link. Okay, so then I have created the communication agent. Okay, so now I have to attach the agent. Okay, I have to connect the both the communication agent. So what is my source communication agent? My source communication agent, I have given the name as TCP. For the destination communication agent, I have given the name as sync. Okay, so now I'm going to connect. That is both the communication agent. I'm going to provide connection. Okay, so that is $NS connect $TCP $sync. Okay, so in the previous experiment, we have seen CBR, the constant bitrate is my traffic source. Whenever whenever I have to accomplish a packet transfer, okay, I have to go with the traffic source. Okay, the traffic source, it comes under application. Okay, so here the application, the traffic source, what I'm using is FTP. Okay, remember in the previous case we have CBR. So we have given inside the square bracket new application the subtype as CBR, but now new application the subtype as FTP, since we have used file transfer protocol as the traffic source here. Okay, and for FTP, set FTP. Okay, so I would like to have the name as FTP, so it is user defined, so it is set FTP I'm mentioning. Okay, so now, so what I have to do, I have to attach my traffic source to N0. So actually my N0 is attached to my source communication agent TCP. So what I'm doing, I'm attaching my traffic source to TCP. Okay, so is that clear to you? So let me just plot this so that you will understand. Okay, I will take a pen. So I have attached my source node. I have attached my source node to TCP. This is my source communication agent. Okay, so my traffic source, I have to attach to TCP. So I have to attach. So I'm attaching my traffic source. What is my traffic source? The traffic source. So it is user defined. I have mentioned the name as FTP. So I'm writing as FTP. So this is my traffic source. Okay. So my FTP, I'm attaching my traffic source. I'm attaching to the TCP. The TCP, it is attached to my node N0. Similarly, what I have to do, so already I have done my destination node N5. It is attached to my destination agent. My destination agent is sync. Okay. Now going back to the program. Okay. So I have some stuff in NS2 like monitor agent. Okay. Monitor hyphen agent hyphen trace. Okay. What it will do means, okay. So we'll be having it will display like this monitors agent. Okay, so here it will show all the events. It will display all the events which are all happening. Okay, to get like this only we have this. Okay, ஸோ இப்போ இது வந்து குடிக்கல அப்படின்னாலும் பிரச்சனை இல்லை. ஸோ நம்ம தான் வந்து எல்லாமே கோடில் வந்து நம்ம சொல்ல போகிறது தான் அதை எக்ஸிக்யூட் பண்ணி காமிக்க போகுது. ஓகே, so trace var means trace variable, CWND means congestion window. Okay, TCP nave you have to remember the most important parameter we have in TCP is congestion window. Okay, so next one, so everything we completed. What is the next step? So I have to mention at what time I'm initiating the packet transfer, at what time I'm going to end my packet transfer. So what are all the events which are going to occur in between? Okay, so here FTP. So since why FTP start, $FTP start, we know this is the syntax. Okay, to start the packet transfer. Okay, so point one, I'm mentioning at mentioning as point one. So 0.1 millisecond it is start. So FTP start. Okay, and I'm going to finish at 2.5. Okay, so these are all we are only deciding. Okay, even if you want like 4, you can mention as 4. Okay, also they have mentioned queue limit. Okay, so suppose even if you are not mentioning, it will take the default value. So இந்த steps எல்லாமே நீ mention பண்ணலனாலும் ஸோ அதுவே வந்து ரன் பண்ணிடும். பட் அடிஷ்னலாக நம்ம இதெல்லாம் வந்து இந்த லைன் எல்லாம் வந்து NS2ல இருக்கு அப்படின்னு நம்ம வந்து லேர்ன் பண்ணிக்கிறோம். ஓகே, ஸோ தட் இஸ் வை வி ஹாவ் ஸோ queue limit. So we are queue size we are setting. Okay, now detach agent. So detach agent, what is, so we know what is attach agent. Between N0 and TCP we have attach. So detach means it will remove. Okay, if I have completed, okay, in TCP what we will do, once it is completed, we will go with the connection termination process. So that is called detach agent. இது வந்து இங்க N0 to TCP, also from N5 to sync வந்து முன்னாடி நம்ம attach பண்ணோம். So here they have mentioned TCP. This will happen at the end. Okay, then I'm calling the finish. Okay, I'm calling the finish procedure. Okay, finish procedure அப்படிங்கிறது at the endல வந்து so we have like, so finish procedure, we have a finish procedure. Okay, so here we are calling it as a procedure. That is the difference. The finish அப்படிங்கிறதுக்கு வந்து ஒரு ஃபங்க்ஷன் செப்பரேட்டா நம்ம ரிட்டர்ன் பண்ணிட்டு ஸோ அதை வந்து எந்த டைமுக்கு கால் பண்ணணுங்கிறத நம்ம மென்ஷன் பண்றோம். ஓகேவா, ஸோ we are calling the finish procedure. Okay, at 2.5. ஓகே, 2.5 ஓட முடிஞ்சிச்சு எனக்கு. ஸோ 2.5 வந்து நான் ஃபினிஷ் ப்ரொசீஜர் வந்து நான் கால் பண்றேன். ஓகே, நவ் ஸோ நெக்ஸ்ட் யூ கேன் சி வி ஹாவ் லைக் சம் கமெண்ட் லைன். ஓகே, ஸோ trace annotate. Okay, so we have in NS2 one command trace hyphen annotate. So it will generate trace annotate file. Okay, it will provide the information about the events at each instant of time, whichever we have mentioned here, trace annotate. So it will display it. Okay, so why? Because in case of stop and wait protocol. Okay, so I hope you know the working of the stop and wait protocol. Let me just take the stop and wait protocol. Okay, the illustration. So what we will do in stop and wait protocol, stop and wait. Okay, I will transmit first packet 1. Okay, then I will stop. Only after getting acknowledgement for the packet 1 from the receiver. Okay, I will be sending packet 1. To put it in a simple way, so packet 1 I am sending it. Okay, then I will stop. Okay, then I will be waiting till getting an acknowledgement for this packet 1. Okay, suppose if I am not getting an acknowledgement for packet 1, so I will assume like the packet 1 is lost. Okay, so then if I haven't received any acknowledgement, what I will do, I will retransmit the time after the timeout. Okay, so stop and wait. I will transmit packet 1. If I have received the acknowledgement successfully, then I will transmit the next packet. Okay, so in this case, what is the scenario they have given us? Packet 1 is sent. Okay, then the receiver, it is sending an acknowledgement for the packet 1. Okay, then it is sending, after receiving this acknowledgement only, it is sending packet 2. Okay, now due to some channel problem, okay, in the packet, you assume the packet 2 is lost. Okay, so it is not receiving any acknowledgement from the receiver, so it is going to assume, so a timeout it is going to occur. So it is going to assume the packet 2 was lost, so it is going to send packet 2 again. Okay, retransmit the packet 2 again. So now it has successfully arrived, so it is giving a confirmation to the transmitter that I have successfully received the packet 2. Okay, so this is the stop and wait protocol. Okay, in the same manner, okay, we are going to give the trace annotate here. Okay, let me just take that page, just 1 minute. Okay, so I'm going to begin at a point 01. Okay, again, see students, whatever we are mentioning the time, it is going to happen only at that time. If you want at point 1, you can mention as point 1, no issues. Okay, now send request from system 0 to system sys 0 to sys 5. Okay, so now receive request from sys 5 to sys 0. Other than the TCP, in either way it will communicate. Okay, if I have a source node, if I have a destination node, both they will do handshake to each other. Okay, so after that only the connection establishment will be completed. After that only it will begin with the packet transfer. Okay, so now it is asking send packet 0. Okay, so then after sending packet 0, it will be waiting for the acknowledgement 0. After receiving acknowledgement 0, I will be sending packet 1. Okay, and here I am going to add a behavior lost the packet 1. Okay, so N2 got disconnected, so packet 1 is lost. So what it will do, it will be waiting. It will be waiting for the acknowledgement. Okay, so so what we will do, we will retransmit whichever packet is lost. We will retransmit that packet. Okay, so then so again we are retransmitting it. So receive acknowledgement 1. After successfully receiving the acknowledgement 1, I am sending packet 2. Okay, then receive acknowledgement 2. So for each and every event, we are mentioning the time at which it is going to happen. Okay, so the to put it in a nutshell, okay, so I am sending packet 0, then I am expecting an acknowledgement for the packet 0. Okay, so then I'm sending packet 1, I'm expecting an acknowledgement for the packet 1. Okay, but here we are illustrating packet is lost. So if packet is lost, so we will retransmit that packet again. Okay, so then after that, after retransmitting, we'll be waiting for the acknowledgement. So after receiving this acknowledgement 1, I'm sending packet 2. So then I'm receiving acknowledgement 2. Okay, so now it is going to finish. Again I'm saying, so what are all the time whichever we are mentioning the code, it is going to work accordingly. So here I'm choosing it as a 2.5. It doesn't mean that it is always it should be 2.5. Okay, so now I have completed all the things I have mentioned. Okay, so now what I have to do, I have to run my simulation. Okay, hope you got an idea about this program stop and wait protocol. Okay, the go back and selective repeat protocol, it also the same. Okay, the same type, only you will be having only slight modifications. Okay, so thank you everyone for watching this video. With this, let me just close it.